In this video, we'll explain the Bayes theorem. Given two events A and B, we're interested in calculating the probability of B given A. But in practice, oftentimes we know the probability of A given B. The Bayes formula or the Bayes theorem is very useful in reversing the order of conditional probability. Let's derive the formula. P of B given A, based on the definition of a conditional probability, is equal to probability of B intersects A divided by P of A. And this is equal to probability of A intersects B divided by P of A. Here we just reverse the order of the intersection. Now this is also equal to probability of A given B multiplied by P of B. This is based on the rule of multiplication of a probability. So divided by P of A. For the denominator, we can go a bit further using the law of a total probability. Let's copy the numerator. P A given B multiply P of B. The denominator is also equal to P of A given B multiply P of B plus P of A given B complement multiply P of B complement. This is often referred to as the Bayes theorem. But this one is actually more useful in practice. Next, we will give some examples on how to use the Bayes formula to solve the real-world problems. Thank you. The probability of having a rare disease is 1 out of a million. A device has a 99% accuracy in detecting the disease. In other words, the probability of a positive test result is 99% given you have the disease, and the probability of a negative test result is 99% given you do not have the disease. If the test result is positive, what is the probability that you actually have the disease? Let's first define the events. Let A equals test positive. B equals have the disease. What we try to calculate is the probability of B given A. Let's first check what we know. So we know that the probability of a positive test result is 99%, given that you have the disease. In other words, what we know is the probability of A given B is 99%. We also know the probability of a negative test result is 99%, given you do not have the disease. In other words, we know that the probability of A complement given B complement is equal to 99%. Okay, so A complement means that the opposite of A, or A does not happen. So let's calculate the probability of B of A. This is where the Bayes formula is useful. It can reverse the conditioning. Let's first calculate the P of B given A using the definition of a conditional probability. So this is equal to probability of B intersects A divided by P of A. And this is equal to P of A intersects B divided by P of A. Note that we just reverse the order of B and A. So this is equal to, look at the numerator. The numerator can be written as probability of A given B multiplied probability of B. This is the property of the conditional probability. For the denominator, we can write the denominator using the law of a total probability. the P of A is equal to P of A given B multiply P of B plus P of A given B complement multiply B P of B complement. Okay, this is the Bayes formula. This basically is the Bayes formula. Let's try to figure out how to calculate each item here. First, we need to calculate P of A given B, and we know this is 99%. Okay, P of B, or the probability of having the disease, we know this is 1 out of a million, so it's 10 to the negative 6. And the first item in the denominator is the same as the numerator, so we can just copy it. Now, P of A given B complement, what we know is P of A complement given B complement. In other words, we know the probability of a negative test result given that you do not have the disease is 99%. But this is the probability of a positive test result given that you do not have the disease. And this is equal to 1 minus P of A complement given B complement. It's the opposite of this. So this is equal to 1 minus 99%, which is equal to 1%. Now let's calculate this item. Probability of a B complement. This is essentially the probability of not having the disease. So obviously this is 1 minus 10 to the negative 6. Now we have all the items here. Let's do the final calculation. So this is equal to 99% multiply 10 to the negative 6. Again, the first item in the denominator is the same as the numerator, so just copy it over. The second item of the denominator is equal to 1% multiply 1 minus 10 to the negative 6. And this is roughly equal to 0.01%. So this is a bit of a counterintuitive. The probability of having the disease given a positive test is only 0.01%. But this is the correct answer using the Bayes formula. Thank you for watching.